Polynomials. A function p is called a polynomial if we have p of x, which is equal to the following. We have a subscript n times x to the power of n plus a subscript n minus 1 times x to the power of n minus 1 all the way to a subscript 0, where n is a non-negative integer and the numbers a subscript 0, a subscript 1, a subscript 2 to a subscript n are constants called the coefficients of the polynomial. Now the domain of any polynomial is all real numbers, which is negative infinity to positive infinity. If the leading coefficient a subscript n is not equal to 0, then the degree of the polynomial is n. So for example, for the function p of x, which is equal to 2x to the 6th minus x to the 4th plus 2/5 x to the 3rd plus the square root of 2, is a polynomial of degree 6 because 6 is the highest degree of the term. Now a polynomial of degree 1 is of the form px, which is equal to mx plus b, and so it is a linear function. If a polynomial of degree 2 is of the form p of x, which is equal to ax squared plus bx plus c, is called a quadratic function. Its graph is always a parabola obtained by shifting the parabola y equals ax squared, as we will see in the next section. The parabola opens upward if a is greater than 0 and downward if a is less than 0. So we can see that in figure 7 here. So here the value of a is positive, so it's opening upward, and over here the value of a is negative, so it's opening downward. Now a polynomial of degree 3 is of the form p of x, which is equal to ax cubed plus bx squared plus cx plus d, where a does not equal 0. Now with a polynomial of that degree of 3, it is called a cubic function. So if we take a look at figure 8, it shows the graph of a cubic function in part A and the graphs of polynomials of degree 4 and 5 in parts B and C. We will see later why the graphs have these shapes. So again, here are your graphs. Now polynomials are commonly used to model various quantities that occur in natural and social sciences. So for instance, in section 3.8, we will explain why economists often use a polynomial p of x to represent the cost of producing x units of a commodity. In the following example, we use a quadratic function to model the fall of a ball.